Hi everyone. Today I'm going to be going over the legal question, container with most water. So first, let's read the question. We're given an integer array height of length n, and there are n vertical lines drawn such that the two endpoints of the ith line are I0 and I height I. And I'll show you exactly what that means in a bit. And we want to find two lines that together with the x-axis form a container such that the container contains the most water, and we want to return the maximum amount of water a container can store. And one thing is that we may not select the container. So let's look at this example, right? So this is our height array or input array, and you can see that each vertical line, one endpoint is at I0 and the other one is at I height I. So basically each of these numbers represents the height of each of these vertical lines. Like this vertical line has a height of 1, this vertical line has a height of 8, and etc. And so this is the most amount of water we can contain. And notice that because we can't slant a container, we have to choose the minimum height each time. So for example, this has a height of 8, this has a height of 7. So we can only use 7 units of height for this one. We can't use 8 because then it's gonna overflow, right? There's nothing on this line that prevents the water from overflowing, and we can't slant the water as well. And so just some more input constraints. So we know that the height array has at least 2 elements, so we don't have to worry about if there's no elements or whatever. So yeah, let me go into the solution right now. So how I'm going to do this solution is to use a 2-pointer algorithm. So our first pointer left, I'll denote as L, and our second pointer right, I'll denote as R. So in the beginning, L is at the first element, R is at the so in the beginning, L is at index 0, R is at index length of height minus 1. And what we're gonna do is left is less than right, and in this case it can't be less than or equal to right because that will just be one line, right? For example, if L and R are both here, then it will just be one line, right? That doesn't that's not a container. So while the left pointer is less than the right pointer, we're gonna have a loop, and for each iteration of the loop, what we're gonna do is we're gonna find the area, the amount of area that can be contained by the container of the height and size, height and width, and we're gonna also have a maximum area variable that's created at the beginning, and we're gonna check, okay, if the current area is bigger than the max area, then we'll update the max area to be the current area. If it's not, then we don't do anything to max area. And what we're also going to do is we're going to update one of our pointers. So because each time we're only going to be using the smaller line, we're going to be moving the pointer associated with that line. So for example, at the beginning, our left pointer has a height of 1, our right pointer has a height of 7, so we will move our left pointer 1 over, just because left has the smaller smaller height. So let me do a quick walkthrough of what I mean by that. So in step 1, right, so left has a height of 1, right has a height of 7, and we're taking the minimum between the two. So our height is equal to 1, our width is equal to 8, so our area is equal to 8. Now, because we want to update the pointer associated with the smaller height, we're going to move left 1 over. So now this will be L. So in step 2, left has a height of 8, right has a height of 7. So therefore the height of our container is 7 because it's the minimum between the two. Our width is 7 because we moved left over. So area is 49. And now in this case, right has the smaller height. So we're going to move that one left. For a third iteration, left is still 8. Right is now 3. So the height of a container in this case will be 3. Our width is 6. So area is equal to 18. And our right pointer still has a smaller height. So we move that over. So now, in step 4, left has a height of 8. Right also has a height of 8, I believe, yes. Right also has a height of 8. So the height that we're going to be using is 8. Our width is now 5. So area is equal to 40. In this case, because both left and right have the same height, it doesn't really matter which pointer you move. For my solution, I'm going to move the right pointer. It doesn't really matter which one you move. So I'm going to move right one here. And let me zoom out a bit. Okay. So in step 5, let me just draw a line here. In step 5, our left is still 8. Our right is now 4, I believe. Yes, 4. So this means that height is equal to the height of the container is 4, and our width is equal to 4. So our area is equal to 16. Right still has the smaller height, so we move it over. Oops. For the 6th iteration, left is still 8. Right is now 5. So that means that the height of our container is 5. Our width is 3. So, 3. That means our area is equal to 15. Right still has the smaller height, so move that over. For the 7th iteration, left still is 8. Right is now 2. That means that the height of our container is 2. Our width is also 2. So our area is going to be 4. And we're going to move right over because it still has a smaller height. For 8th iteration, left is equal to 8. Right is equals to 6. 6. So that means that the height of the container is equal to 6. Our width is now 1. So area is equal to 6. And when we move right over, left and right will be together, right? Like they'll be at the same spot. So now it doesn't constitute a container, it's just a line. So we stop. And we notice that this is our like the biggest amount of water we can contain, and hence that's what we return. And again, we're gonna have like a maximum area global variable to keep track. So now let me code this out. So the first variable I'm gonna make is the max area pointer. So the max area variable, and I'm gonna make it. I'm gonna initialize it to be like the smallest possible value. And I'm gonna have a left pointer and a right pointer. So again, left starts out at index 0, right starts out at index length height of minus 1. And like I mentioned, so while the left pointer is strictly less than the right pointer, again, because if they're the same, then it's a line, but it's not a container. Then what we're gonna do is first let me get the height of each of the lines. So this just gets the height of the left line, and this just gets the height of the right line. And our h is going to be the minimum of those two. So basically what I'm doing here, right, like this part, our left, right, and then our h, and our width w is equals to r minus l, and our area is equals to height times width. Again, basically the same thing as I showed here, right, like what I did here. And now we're gonna update our max area if the area is bigger than it, right? So max area is essentially the max between itself and area. And now we're gonna do the check. So if h1 is less than h2, then left moves right by 1. Otherwise, right moves left by 1. And finally, we return max area. So again, this is exactly what I documented, like what I drew on the whiteboard before. Like we have 2 pointers. At each step of the iteration, we get their respective heights. We find the minimum between the two heights. We also get the width. From the height and width, we get the area, and we just keep track of the biggest area that we've seen. And then after we calculate the area, we decide which pointer to update. If the left pointer is smaller than the right pointer, we update that one. If the right pointer is smaller than the left pointer, we update that one. If they're the same, it doesn't really matter. In this case, I just chose to update the right pointer. Let me just make sure that I didn't miss anything. Each one's height. Okay, I think that should work. Let me do a quick test run. Okay, it works. Let me submit. And yeah, you can see this is the solution. So and also the time complexity is O of n because we're only making like one loop to the way, right? So yeah, so that's the solution. Thanks for watching.